It's estimated that there are roughly 200 billion galaxies and 70 quintillion stars in the universe. But the famous English physicist and professor of particle physics, Brian Cox, claimed in an interview on the BBC that Earth is the only planet where life exists, and we are the only civilization in the universe. Could it really be possible that Earth is the only planet where life exists? Many famous scientists believe that intelligent civilizations must exist beyond Earth, and that they have existed throughout the course of the history of our universe. For instance, Carl Sagan believed that there might be 1 million civilizations in the observable universe. But why does Brian Cox believe that there's no intelligent life beyond Earth? What evidence proves that we are the only intelligent civilizations in the universe? Let's delve in and find out. In a statement made on BBC One's Sunday morning show, Professor Brian Cox expressed skepticism about the likelihood of intelligent life beyond Earth. While he acknowledged the possibility of widespread microbial life, he argued that the emergence of advanced civilizations like ours might be extremely rare. Cox pointed to the timeline of life on Earth as a basis for his opinion. He highlighted that evidence suggests life existed on our planet approximately 3.8 billion years ago, but it took about 4 billion years for civilization to arise. Given the vast age of the universe, which is roughly 13.8 billion years, this time frame indicates that advanced civilizations like ours could be unusual occurrences.
If civilizations are common, or even slightly common, then there should be civilizations ahead of us, because there's been so much time. You imagine the timescales. We've been around as a civilization. Let's give it, say, 40,000 years. I don't know how long our civilization's been around. Let's say that. The galaxy is pretty much as old as the universe. It's 13 billion years worth of time. So the idea that there are no civilizations arose, 100 million years ago, 200 million years ago, 1 billion years ago. And imagine what they'd be like if they'd survived. I mean, we've been around, we've had science for, let's say, since Newton or Copernicus, 500 years at most. And look what we've done. We've gone beyond the solar system with Voyager. We've walked on the moon. We're about to go to Mars, I would think. So we're about to begin colonising our own solar system. We've done that in 500 years. So imagine 1 million years. It's one of the arguments often used to say there aren't any civilizations out there in the galaxy. It's called the Fermi paradox. Because if you imagine a civilization that's 1 million years ahead of us, they should have written their presence across the sky by now. They should just see it. If we survive 1 million years into the future, actually even a few thousand years into the future, we will be exploring the galaxy. We will have spacecraft that are going to other stars. We will be doing it. So our signature will become visible, I'm sure, if we last.
The rare Earth hypothesis. The rare Earth hypothesis postulates that the emergence of complex life, particularly intelligent life, on Earth-like planets is an exceedingly rare occurrence in the universe. This theory, proposed by paleontologist Peter Ward and astronomer Donald E. Brownlee in their book Rare Earth, Why Complex Life is Uncommon in the Universe, posits that a specific set of conditions are required for life to develop and evolve into advanced forms, and these conditions may be rare or unique to Earth. According to the rare Earth hypothesis, several factors contribute to the uniqueness of Earth as a haven for complex life. The first critical factor is the presence of a stable and long-lasting star, which provides a consistent source of energy. Our sun's stability has allowed life to thrive on Earth for billions of years. In contrast, stars prone to intense solar flares or other violent activity might sterilize any potential nearby planets. The second vital aspect is the composition of our solar system. Earth resides in the habitable zone, a region around the sun where conditions are just right for liquid water to exist on the planet's surface. This prerequisite for life, known as the Goldilocks zone, might be uncommon in the galaxy due to specific requirements for a planet's distance from its star and the star's luminosity. Furthermore, the presence of a large moon has displayed a significant role in shaping Earth's environment. The moon's gravitational pull stabilizes Earth's axial tilt, resulting in relatively stable climate conditions. Without a sizable moon, a planet could experience extreme climate fluctuations, making the development of complex life less likely. The Earth's unique magnetic field is another factor highlighted by the rare Earth hypothesis. This protective shield deflects harmful solar and cosmic radiation, safeguarding life on the planet's surface. Planets lacking a strong magnetic field might be more vulnerable to these harmful radiations, making the emergence of life challenging. Plate tectonics, a geological process occurring on Earth, also contributes to the planet's suitability for complex life. The movement of tectonic plates helps regulate the carbon cycle and maintain a stable climate. Without such activity, a planet might experience volatile climate changes that hinder the evolution of life. The rare Earth hypothesis also suggests that the presence of complex multicellular life requires a series of rare events. For instance, the transition from single-celled to multicellular organisms involved intricate processes that might not occur on every planet. Moreover, the development of complex nervous systems and intelligence is seen as a rare occurrence, as evidenced by the relatively few intelligent species on Earth. The Great Filter Theory. The Great Filter Theory proposes a significant obstacle, or filter, that acts as a barrier preventing the development of advanced civilizations in the universe. This theory suggests that while simple life might be common, the emergence of complex, intelligent civilizations capable of interstellar communication and exploration is rare due to a critical and challenging step. The concept of the Great Filter is a framework introduced by economist Robin Hanson in 1998 to address the Fermi paradox, which is the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of observable evidence for their existence. The Great Filter represents a crucial point in the evolution of life, where many potential civilizations may falter or fail to progress further. The Great Filter could be located at various stages of a civilization's development, each representing a possible hurdle that most civilizations may not overcome. One possible filter is the emergence of life itself. The transition from non-life to simple life forms could be an extremely rare event, requiring specific conditions and chemical processes that only occur under unique circumstances. Another potential filter is the development of complex multicellular life. The evolution of complex organisms with specialized cells and structures might be a challenging and unlikely step. Many planets could be home to simple life, but the emergence of complex life forms could be constrained by various factors, such as environmental changes or competition between species. The development of intelligence and technological civilization represents a critical juncture that might act as the Great Filter. While intelligence has evolved on Earth, it's unclear how common this occurrence is. The transition from basic survival instincts to the ability to manipulate tools and develop advanced technology could be a rare occurrence in the universe. Additionally, the ability of a civilization to avoid self-destruction is a potential filter. Technologically advanced societies might face existential risks such as nuclear warfare, ecological collapse, or societal instability. The challenges associated with managing advanced technology and navigating potential global crises could lead to many civilizations to a downfall before they have a chance to communicate or explore beyond their own planet. The ability to sustain long-term interstellar communication and exploration could also represent another filter. Even if civilizations overcome earlier hurdles, the vast distances between stars could limit their ability to establish contact with one another. The challenges of space travel, communication delays, and the logistics of interstellar exploration could hinder the spread of intelligent life across the cosmos. The Fermi Paradox. The Fermi Paradox poses the puzzling question of why, despite the high probability of the existence of extraterrestrial civilizations, we have yet to observe or communicate with any of them. This enigma was named after physicist Enrico Fermi, who famously asked, "Where is everybody?" The paradox has spurred numerous theories and conjectures in an attempt to reconcile the seeming contradiction between the vast number of potentially habitable planets in the universe and the absence of definitive evidence for alien life. One explanation for the Fermi paradox is that advanced extraterrestrial civilizations might indeed exist but are too distant for us to detect or communicate with. The vastness of space and the limitations of our current technology could hinder our ability to establish contact. Interstellar distances are so immense that even with advanced propulsion methods, the time and energy required to travel between star systems would be formidable. Moreover, electromagnetic signals, such as radio waves that might carry messages from distant civilizations, could become weak and undetectable over cosmic distances.
There is an argument as well that technology so advanced would be difficult for us to detect. I mean, we tend to think of as starship that you can see the signature of. But actually it may be that the civilization just becomes a nano-civilization because that's more efficient. It's a better way to do things. So it's possible, I suppose, that there are space probes all over the place that are so small and are so efficient and use so little energy that we just don't see them. I suppose that is possible.
Another possible resolution to the Fermi paradox is that advanced civilizations may have self-imposed limitations on communication or expansion. Civilizations could intentionally avoid broadcasting their presence to avoid attracting unwanted attention from potential adversaries. Alternatively, ethical considerations might lead them to remain hidden to observe developing civilizations without interference. This zoo hypothesis suggests that advanced civilizations are actively observing us, but we remain unaware of their presence. The concept of technological singularities provides another perspective on the Fermi paradox. It postulates that civilizations could experience rapid and transformative technological advancements, reaching a point beyond which their actions and intentions become incomprehensible to less advanced societies. This hypothetical post-biological phase could involve the emerging of artificial intelligence with biological entities or the development of highly advanced simulations of reality. Such civilizations might no longer interact with the physical universe in ways that we can perceive. Cultural and linguistic barriers could also contribute to the Fermi paradox. Communication with extraterrestrial civilizations assumes a shared language or communication medium, which might differ significantly from our own. Additionally, alien intelligences might use unconventional methods or channels for communication that we've not yet discovered or deciphered. A fundamental aspect to consider is the concept of the anthropic principle. This principle suggests that the observed conditions of our universe are uniquely suited to the emergence of life and intelligent beings. If certain physical constants or parameters were even slightly different, life as we know it might not have arisen. This rare set of circumstances could explain why we've not yet encountered other civilizations, as the conditions necessary for their existence might be extremely specific. Environmental and cosmic factors could also play a role in the Fermi paradox. Catastrophic events such as gamma-ray bursts, supernovae, or asteroid impacts might pose existential threats to civilizations, leading to their extinction before they have the chance to communicate or explore beyond their home planet. Additionally, the habitable zones around stars might be narrower than initially thought, reducing the number of planets suitable for life. Technological stagnation hypothesis. This hypothesis suggests that while civilizations may advance to a certain level of technological achievement, they could encounter barriers that prevent further progress, leading to a stagnation of development and ultimately limiting the exploration of space and the universe. At its core, the technological stagnation hypothesis proposes that despite early strides in scientific understanding and technological innovation, civilizations may reach a point where they face formidable challenges that impede their continued advancement. These challenges could stem from a variety of sources, including limitations in energy resources, the exhaustion of essential raw materials, or the constraints imposed by the fundamental laws of physics. One aspect of this hypothesis involves the concept of energy availability. As civilizations progress, their energy demands may increase significantly due to technological expansion, population growth, and other factors. However, if access to abundant and sustainable energy sources becomes scarce or unattainable, civilizations might struggle to maintain the momentum of technological development. Without adequate energy, the exploration of space and the colonization of other planets would become exceedingly difficult. Another potential hurdle is the finite availability of critical resources. Technological advancement often relies on the availability of materials such as metals, minerals, and rare elements. If these resources become depleted or difficult to access, the construction of advanced technologies and infrastructure could be hampered, leading to a plateau in progress. The technological stagnation hypothesis also raises the possibility of encountering physical limits to innovation. Certain fundamental laws of physics, such as the speed of light, could impose insurmountable barriers to interstellar travel and communication. If these limits cannot be circumvented, civilizations might find themselves confined to their home planets, unable to explore and expand beyond their own star system. Additionally, societal and cultural factors could contribute to technological stagnation. As civilizations mature, they may grapple with complex ethical, political, and economic considerations that divert resources and attention away from scientific and technological pursuits. Conflicts, competing interests, and societal divisions could hinder the allocation of resources necessary for sustained progress. Communication barriers. One intriguing perspective on the apparent absence of extraterrestrial civilizations is the communication barriers hypothesis. This notion proposes that while advanced civilizations may exist elsewhere in the universe, the challenges of communication and detection could hinder our ability to establish contact and interact with them.
So it's not bonkers to suggest that life may have begun somewhere else other than Earth, right? That we're looking for it in the solar system. But what is really worrying observation to me actually is that we've looked a bit for radio signals and we look out for signs of anything out there in our galaxy, intelligence, and we don't see anything at all. And astronomers call it the Great Silence. It's kind of an ominous name because it seems there's so many planets, 20 billion potentially Earth-like planets in the Milky Way. You think there's loads of room and loads of time, so there should be things out there, but we don't see anything. And the explanation probably, if indeed that's true, is biology. It's just, if you look at the history of life on Earth, it took nearly 4 billion years from the first cell to a civilization. 4 billion years, nearly. That's a third of the age of the universe. I think the best guess is that we're so incredibly fortunate to be here, because it's just that ask that you say, I want a planet to support an unbroken chain of life through all this violence in the universe, an unbroken chain of life for 4 billion years in order to get to something like you and me, right? Collections of atoms that can think. I think it's just really unlikely. It's terrifying and also kind of uplifting in a way, isn't it? Because it means that we're unbelievably valuable as a species and a planet. It could be. We're the only island of meaning in an ocean of 400 billion suns.
The communication barriers hypothesis acknowledges that the methods and means of communication may differ significantly among potential extraterrestrial civilizations. Human communication relies on a combination of spoken and written language, as well as the use of electromagnetic signals like radio waves for long-distance communication. However, it's possible that other civilizations might have developed entirely distinct forms of communication that we're not equipped to recognize or decipher. Furthermore, the vastness of space presents significant challenges to communication. Even if two civilizations were transmitting signals, the time it takes for those signals to travel between star systems could be immense. This delay could make meaningful, real-time communication nearly impossible. The distance between stars also affects the strength and detectability of signals, potentially limiting our ability to receive or send messages across interstellar distances. Additionally, the communication barriers hypothesis takes into account the possibility that advanced civilizations might intentionally avoid detection. This could be motivated by concerns about interference, invasion, or unwanted attention. Just as humans observe and study wildlife without direct interference, extraterrestrial civilizations might choose to observe developing civilizations from a distance to avoid disrupting their natural development. Another consideration is the potential differences in technological development. If two civilizations are at vastly different levels of technological advancement, their methods of communication may not align. For instance, a highly advanced civilization might use methods of communication that are beyond our current understanding or technological capabilities. Conversely, a less advanced civilization might struggle to detect or interpret signals from a more advanced counterpart. The communication barriers hypothesis also raises the possibility of limitations in our ability to detect extraterrestrial signals. Our current methods of searching for alien communications are based on our own technological framework, which might not align with the methods used by other civilizations. If our assumptions about the frequency range, signal type, or communication medium are incorrect, we could be missing potential signals from advanced civilizations. Cultural and physiological factors may play a role as well. The ways in which different civilizations perceive and interpret signals could be influenced by their unique cultural perspectives and cognitive frameworks. This could lead to misinterpretation or misunderstanding of signals, hindering meaningful communication. Moreover, the inherent uncertainty of the universe could impact our ability to establish contact. The cosmic vastness and randomness of celestial events might result in civilizations emerging, flourishing, and disappearing in relative isolation from one another. The chances of two civilizations existing simultaneously within close proximity and possessing the capability for communication might be rare.
A radio telescope called the Big Ear detected a radio signal from somewhere in the vicinity of the constellation Sagittarius. And this is the printout from that night. It was a pulse. The peak brightness was over 30 times the brightness of the background radio emission from the galaxy. That's the wavelength of light, of radio waves emitted from hydrogen atoms. So the whole sky glows at that wavelength. And back in the 1950s, radio astronomers speculated that if an alien civilization wanted to communicate with us, then they might well choose that very special, natural wavelength to send their message. So surprising is this, that when it was spotted a few days later by an astronomer called Jerry Amon, he circled that pulse, a 72-second flash of radio waves, and wrote "wow" next to it. So this has become known as the WOW signal.
Now, let's discuss what suggests that life exists beyond Earth and what arguments are proposed by scientists. One of the most compelling arguments for the possibility of life elsewhere lies in the adaptability of life on Earth itself. From the depths of the ocean to the most extreme acidic environments, life has proven its ability to survive and even thrive in conditions that were once thought to be inhospitable. This adaptability hints at the potential for life to exist in a wide range of environments across the universe. Intriguingly, the building blocks of life, organic molecules, have been discovered not only on Earth but also in the depths of space. Amino acids, the foundational units of proteins, and life as we know it, have been detected on comets and in interstellar clouds. The presence of these molecules in space implies that the raw materials for life could be widespread, increasing the likelihood of life emerging on other planets. The significance of water in the search for extraterrestrial life cannot be overstated. Water is essential for biochemical reactions and provides a medium for life's processes to occur. The discovery of water ice on celestial bodies like Mars, Europa, and Enceladus has fueled hope that subsurface oceans might exist, providing potential havens for life away from the harsh conditions of space. The concept of the habitable zone further bolsters the argument for extraterrestrial life. This zone refers to the region around a star where conditions are just right for liquid water to exist on a planet's surface. Exoplanets within this zone offer the tantalizing possibility of environments suitable for the emergence and evolution of life. The Fermi paradox, named after physicist Enrico Fermi, raises thought-provoking questions about the apparent absence of extraterrestrial civilizations. Given the sheer number of potentially habitable planets, it is reasonable to assume that other intelligent life forms should have emerged and developed advanced technologies. Yet, our search for extraterrestrial signals has remained fruitless, leading to speculation about potential explanations. One proposed solution to the Fermi paradox is the notion of the Great Filter. This hypothetical concept suggests that there may be significant challenges or obstacles that prevent civilizations from advancing to the point of interstellar communication or travel. These challenges could be cosmic in nature, such as the development of sustainable energy sources or the avoidance of self-destructive behavior. In our pursuit of answers, initiatives like the Search for Extraterrestrial Intelligence, SETI, continue to scan the skies for potential signals from other civilizations. While no definitive signals have been detected, the advancements in technology and the expansion of our search parameters continue to enhance our ability to explore the universe for signs of intelligent life. Unexplained phenomena, although often attributed to natural causes, occasionally fuel speculation about possible extraterrestrial activity. The erratic dimming of Tabby's star, for instance, ignited discussions about the potential presence of an advanced civilization capable of engineering such changes. A fascinating consideration is the potential for advanced technological civilizations to possess capabilities far beyond our current understanding. As we observe the rapid progression of technology on Earth, we must acknowledge that other civilizations, if they exist, could have developed modes of communication, energy generation, and space travel that remain beyond our grasp. So now, what are your thoughts? Do you believe in the possibility of intelligent life beyond Earth? Tell us in the comments section. Thanks for watching.